Okay, in today's videos we're going to look at the greatest integer function, and then we'll talk in the upcoming videos about piecewise functions. There's going to be probably quite a few videos here. As always, watch until you feel like you have an idea of what's going on and then practice the homework. But I'm going to try my best to go pretty quickly here while still keeping the level of detail high, just so that we can all make sure that we're all on the same page. So we're going to introduce now a brand new parent function called the greatest integer function, abbreviated GIF. And the greatest integer function has a brand new equation, which we've never seen before. It looks like kind of a double bracket around x. This is the symbol for the greatest integer function. So if you ever see that kind of double bracket, we're looking at the greatest integer function. And the question now is, how does it work? Well, for integers, that is whole numbers, positive or negative, it's a very easy function to evaluate. So when x is -1, what is double bracket -1? Or what is the greatest integer of function evaluated at -1? And it's just -1. In fact, that's true for every whole number. If you plug that in for x into your double brackets, it just spits out the same answer. So very easy. It looks like when x is -1, y is -1. So the point -1, -1 is on the graph of this function. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So all of the points, when x is 3, y is 3. When x is 4, y is 4, so on. Same with negative numbers, you know. So we have this. Okay, the temptation would be to draw a line through that, but that is not, unfortunately, what this graph ends up looking like. But hopefully you're okay with why, at least for with integers, when you plug in integers into the greatest integer function, you get out the same answer. So let's look at things that are not integers, like decimals or fractions. So what about like 1.3 or 2.8 or 3.999? What happens when you plug those numbers into the... So when x is 1.3, what's y? What's double bracket 1.3? And what this does, and integers kind of in the name, but it's honestly a kind of a misleading name. What it's going to do is it's going to take any number inside of these double brackets and it's going to round it down to the nearest integer. That's a little misleading because you'd think greatest means round it up, but it's actually rounding it down. So double bracket 1.3, if we round that down to the nearest integer, that's 1. Okay. What about double bracket 2.8? Well, if we round that down to the nearest whole number, 2.8 rounded down gets rounded down to 2. Even this, what's double bracket 3.999? Well, it gets rounded down. So even though 3.999 is super close to 4, it's going to get rounded down, or rounded to the left, down to 3. So if you imagine this on a number line, what is happening? If you imagine this on a number line, here's 4, here's 3, here's 3.999, and yet the greatest integer function takes it to the left or down to 3. Okay? So what's this going to mean for our graph? And this may require some zooming, for any number between 1, it's going to get taken to a height of 1. For any number, it's going to look like this. Okay, it ends up looking like a stair step, a bunch of stairs with closed circles on the left, and actually there are open circles on the right. Okay, so the graph's kind of hard to visualize just by thinking about kind of what numbers get plugged in, right? If you plug in a 1.5, you get out a 1. If you plug in a 1.9, you get out a 1. If you plug in a 1.1, you get out a 1. So any number less than 2 but bigger than 1 is going to go to a height of 1. Okay, so it ends up looking like this. The easiest way to graph this from memory is just to draw your dotted lines on the diagonal like we did, and then draw lines going to the right, and then open circle to the right, open circle to the right, open circle. And we'll get the greatest integer function, at least visually. Okay? Cool. Let's do a couple more just for practice on how to evaluate this thing, just because I'm going to have you do it here in a little bit. What if x is a negative number? Like, what about like negative 1.6 or negative 2.8? What is double bracket, or the greatest integer function of negative 1.6? What does this equal? And if we think about this, it's probably easiest to think about it on a number line, because the term rounding down is a little bit confusing when you talk about negative numbers. So let's let this be 0, here's maybe negative 1, and here's negative 2. Then negative 1.6 is around here, right? This would be like negative 1.6. So the greatest integer function takes things that aren't whole numbers, like decimals, and moves them or rounds them down to the nearest whole number that's less than that. So it's rounding down to the left. So if you were not thinking very quickly, you might say, oh, negative 1.6 rounded down is negative 1. And I would know what you mean, but remember, with negatives, rounding down, that's to the left. So actually, the answer is negative 2. So you should be super careful when you're evaluating the greatest integer function with negatives. Let's look at one more. Negative 2.8. Really, all this is asking is, what's the whole number that's to the left of this? And if you just take a quick second and plot where negative 2.8 is on a number line, here's negative 2, negative 2.1, negative 2.2, negative 2.8 is way over here. And if we round this down to the left, we're going to get negative 3. Okay? Awesome. So now that we have all this, let's look at some features of this graph. Where's maybe the easiest one? Where's the y-intercept? And that's pretty clear. I think it's at the point 0, 0. Okay. What's the domain of this function? The domain is actually all real numbers. It's infinitely wide. The range is actually pretty tricky because the range is, well, like negative 5 is in the range, negative 4 is in the range, negative 3, negative 2, negative 1, 0 is in the range. All of these whole numbers are in the range. But notice, stuff that's like in between whole numbers is not in the range. For example, here, whatever this number is not in the range because there's no y values that hit that height. So the range of this is actually just all whole numbers or integers. Okay. We can look at the end behavior as x approaches infinity, y approaches, and then we'll fill in the blank. As x approaches negative infinity, y approaches, and we'll fill in the blank. As x approaches infinity, what's going on the far right of the graph, and it's just going up forever. In a weird way, it's kind of stair step, but it's just going up to infinity. And the same is true as x approaches negative infinity on the far left. We're just going down and down and down towards negative infinity. Okay. We'll look at x-intercepts last really quick. We would all agree that this is discontinuous. It is actually going to be constant, all those flat pieces, So it's going to be constant everywhere, though just at different heights. It's never purely going up. It's just flat, 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 constant, constant, constant. And then, is it even, odd, or neither? This is actually neither even nor odd, although we haven't learned what that means yet, but we will eventually. So the last thing in this video, I'll probably leave these for when we get together in class. Yeah, just because we just spent some time learning how to find double bracket of some numbers. Remember, round down to the left. So the last thing in this video is just going to be finding the x-intercepts. So let's zoom in here. X-intercepts. That's where it crosses the x-axis. And here is the only place that looks like it might be crossing the x-axis, and it is, but where is it crossing the x-axis? Because it's crossing the x-axis at a bunch of points, right? Like it crosses the x-axis here, 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 here. It's always crossing the x-axis for all of this, right? So from 0 all the way up to 1, it's crossing the x-axis. And so how would we write that as a notation? Well, it looks like 0 is a closed circle, 1 is a open circle. So if we were going to write that in our notation, we would say that the x-intercepts are all of the numbers between 0 and 1, including 0, but not including 1. The x-intercepts are a bunch of numbers, 1/2, 1/3, 0.5, 0.23. There's a ton of numbers that are touching the x-axis, and all of them are from 0 to 1, including 0, not including 1. Okay? And that's the greatest integer function. It's a weird function that we're not quite used to, and honestly we're not going to use a whole lot in this class until much later in the year, but it is a very important function for calculus, so we're just kind of introducing you to it